So let us see the next topic under electrical circuit analysis, that is mesh analysis with dependent source. Probably you might have done a mesh analysis with a independent source, which will be very easy to apply a KVL for the loop and determining the unknowns over there. So let us see what happens if there are a dependent source in the circuit. So we are aware of that, how the dependent source will be given in the circuit, which will be described in this way. If it is an independent source, current source, so this is my current source, either a direction will be upward or downward, which is my independent current source. Similarly, if there is a voltage source, okay, either polarity, whether plus or minus, this is my independent voltage source. So whenever we have a dependent source, so it will be four type of a dependent source. It could be your voltage source, that is current control voltage source. If it is a 10 into I2, it is a current controlled voltage source. This voltage source is controlled by the current. If I am giving the value here 10, right? So this voltage source value is 10, which is controlled by the current source. Similarly, there could be chance of a voltage current control voltage source. So it could be, let me take the value something 5 into I1. If I take, it is a current control current source. Similarly, if it is a current control voltage source, it will be in this way. It will be, the current will be, once again, if I take a 2 amps current, it is controlled by a voltage source. Let me take as a V1 or V2, right? So this is a current controlled current source, current controlled current source, triple CS I can say, right? Or it could be your, this is voltage controlled current source. This is my current controlled voltage source. Similarly, I can have one more, that will be of voltage control voltage source. If I have a voltage and it is controlled by voltage source, voltage control voltage source. So there may be different names for this, they may call in the other way. For example, so this they may call as a current dependent current source. Instead of saying current control, they may say current dependent. So this also current dependent current source, right? So this could be your current dependent voltage source, and this could be your voltage dependent voltage source. They may call in different names also, both are same. So let us take now a problem which consists of this kind of dependent source, and we will try to solve the problem using the mesh analysis. Mesh analysis. So take this network, so which is given with a current source, change the color here for dependent and other source. So I will take a blue color for a independent source which is of plus and minus 5 volts. Okay, and let me take a dependent source with a green color. Independent source, let me take the polarity for that plus minus. And one more resistor connected to one more dependent source. Once again the polarity is plus and minus. And this circuit will continue for the second loop. So this is a circuit. We have the values for this. This is a 10 volts source, and this is my 10 ohm resistor, and this is my 5 ohm resistor, and this is my 5 ohm resistor, and the value for the dependent source, this is 5 into I1. So this is a voltage source which depends upon the current dependent voltage source. So here also have similar a current dependent voltage source. So this depends upon the current I1, this depends on the current I2, and in the circuit they are given a branch current. So let us take this as a branch current I1. Don't get confused with the branch current and the loop current. So these are the branch currents I1, I2, and I3 is mentioned here. I will consider a loop current because since there are two loops, let me take this as a loop 1. The current flowing is I1, and in the loop 2 the current flowing is I2. Okay, the names of the branch current and the loop current look similar, but they are not same. Okay, this is a loop current, this is a branch current. Let us see how to apply a KVL. So let us apply KVL for the loops. KVL for loop. Let us give the loop names to avoid the confusion. I will take this as a this node as a B, this C, D, E, F. Now apply a loop for A, B, E, F, A. So whenever I say applying a loop, so I am starting from the node A, I will need to come back to node A. That is a complete loop. The current will flow from this point and will come back to the point A here. Okay, that is a thing. So now I will write an equation for this. Let me take this one. So here the current I consider I1 I can equate with the voltage source initially, since the voltage was given. Phi is equal to the voltage source in the first loop is 5, that is equal to, so the first resistance is 5 ohms, the current flowing here is I1 into 5 or 5 into I1 plus there is a dependent source. I will consider the dependent source as it is. So there will be, whenever I am writing a KVL with respect to dependent source, I will not consider any loop current for that, because already it is dependent on some current. So hence I will not multiply with the loop current. I will take the value which is given as a 10 into I2. 10 into I2. Right? So this is a, So just I will take a screenshot of this, so it will be easy to do the checking here. So I will keep here only that diagram. So 5 into I2, 5 into I2 plus 10 into, so look at here, I am taking this resistor now, and the current flowing is I1. Don't get confused, because since the branch current is I3, that is not flowing into my 10 ohm resistor, because I am taking a loop current. I1 is a loop current. 10 into I1. For the same resistor, there are two currents are acting. For the same resistor, this resistor, the two currents are acting. So which are those? That is your I1, I2. If you look at here, I1 is also flowing, and if you look at here, I2 also flowing. Both current are flowing into my 10 ohm resistor. Hence, I need to consider both for a equation. So I will just undo those things. So I'll come back here. I have taken 10 into I1, which is plus. Since the current I2 is opposite to the loop which I have considered, that is opposite to my current I1. Hence, it will be minus 10 into I2. It minus 10 into I2. So then there is one more dependent source, which will be plus 5 into I1. Once again, there is a dependent source. I am not considering the loop current. So already it is saying that it is dependent on I1. Hence I have taken this one. So this is my first equation. If I simplify this, if you look at here, so minus 10 I2 plus 10 I2, it get cancels. So left out is 10 I1 plus 5 I1, 15 I1 plus 5, that is 20 I1. So that will be equal to 5 is equal to 20 I1. So hence I1 is equal to 0.25 amps. So this is a loop current, that is I1. So next we will go KVL for second loop. KVL for, instead of writing the all node values, I can say simply loop 2 also. It will be for loop B, C, D and E, and coming back to B. Okay, it will start from B, it will go to C, D, E and B. So I will write the equation starting from this 5 ohm resistor. I will take from there. So it will be 5 into the current flowing in that loop is I2 plus, I will go back there, plus I have a voltage source. The voltage source is plus 10. Why plus? Because the direction is hitting to the plus terminal over here. It is hitting to the plus. Initially it is plus. If it is minus above, then I would have taken minus. Okay. So next, after this I have a dependent source. So it is 5 into I1 plus 5 into I1 plus 5 into I1. So it should be taken minus, because it is hitting, this loop is hitting to the minus. Just now I said here, so it should be minus. Hence I will take here as a minus 5 I1. So after this I have a 10. So 10 into I2 plus 10 into I2. Since already we have taken that there are two current acting for this 10 ohm resistor, I2 and I1. Now I2 is plus, I1 is coming opposite to I2. So hence it will be minus 10 into I1, that equal to 0, equated to 0. So I will equate this equation with respect to 10. So let me take 10. 10 is equal to, I will take left out terminal to the RHS side. It will be minus 5 I2 plus 5 I1 minus 10 I2 plus 10 I1. So I need to simplify this. So look at the term here. I have I1, two terms, is 5 plus 10. So I will write that 15 I1, right, 15 I1 plus I have I2 term, so I2 term is minus 5 minus 10, it will be minus 15, it will be minus 15 I2, so 10 equal to minus 15 I2. So in this equation I will substitute for I1 which we got above, so this value I will substitute for I1, that will be equal to 10 equal to 15 into I1 value we got as a 0.25 minus 15 into I2. So if I simplify this equation, I will get I2 as minus 0.4166 amps. So these are the two values which I got from this network. If they ask to determine the branch current I3, or if they ask to determine the current in 10 ohm resistor, if they ask to find the current in 10 ohm resistor, if you look at this current in 10 ohm resistor is two currents are coming based on this loop, I1 is positive, I2 is negative, that will be, so the current flowing through that is I3, you can see the branch current is I3, I3 will be equal to I1 plus I1 because it is in the same direction of I3, and I2 is coming opposite to I3, it will be minus. So hence if you want to determine current through 10 ohm resistor, that will be I3, which is given I3 is equal to I1 minus I2. So we just know we got I1 I2. If you substitute that value, and you will get the answer as 0.667 amps. So this is the current through a 10 ohm resistor. Okay, hope so you got the how to do whenever we have a dependent source in the circuit, right? So whenever we consider the KVL, we are not going to consider the loop current for that because already it is depend on some other parameter. That is the only one care we should take when applying this. Okay, this is how we do the mesh analysis with a dependent source. Okay, thank you.